the biting silence of prehistoric winters, early humans discovered that survival depended as much on the embrace of warmth as on the hunt for food. The frozen expanses of Pleistocene Europe were a landscape carved by relentless glacial winds, jagged stone ridges and forests that shifted under the weight of ice and snow. Life was measured in degrees, not hours. A single night spent unprotected could claim the weak, and even the robust required ingenuity to persist. For these early humans, the very act of sleeping, so routine in our modern era, was a nightly negotiation between vulnerability and the preservation of life, a ritual demanding attention, observation, and a deep connection to the environment. Their shelters, often natural caves or rocky overhangs, were carefully curated spaces, shaped both by necessity and subtle artistry. The floor of a cave was rarely left bare. It became a living system, layered with materials chosen for their thermal and tactile properties, creating a micro-environment that could resist the penetrating cold. Grasses harvested from frozen meadows, moss gathered from sheltered valleys, leaves dried to resist moisture, and furs stripped from animals hunted for sustenance all contributed to these sleeping platforms. The layering was deliberate. Denser materials at the bottom provided insulation against the cold. Middle layers cushioned the body and stabilized posture, while softer top layers offered comfort and trapped the residual warmth of the human body. This arrangement was not arbitrary, but the culmination of generations of observation and refinement. Human ancestors, attuned to every subtlety of touch and temperature, understood that a bed was an ecosystem in miniature, a dynamic system balancing thermal regulation, moisture management, and support for skeletal and muscular health. The concave depressions naturally formed by repeated use were reinforced over time, with additional plant matter and fur, shaping ergonomic contours that supported sleep positions which reduced strain and preserved energy. The placement of these beds within caves also reflected acute environmental awareness. Proximity to fire pits was balanced with the need to avoid smoke inhalation, while drafty entrances were blocked with natural barriers of stone, animal hides, or carefully packed vegetation. The spatial arrangement of bedding also reinforced social structure and security. Groups would often cluster their sleeping nests, bodies radiating warmth to one another, while weaker or more vulnerable members were strategically positioned to maximize protection from predators and elements. Archaeological analysis of some of the earliest known bedding sites, such as those in South Africa's Wonderwork Cave and Europe's Abri de la Madeleine, reveals layers of ash interspersed with grasses and leaves, suggesting repeated burning to sterilize bedding, repel insects, or add warmth. Even the smallest details, the direction in which a body was oriented, the placement of insulating layers beneath limbs, the way furs were folded, demonstrate a profound understanding of thermal physics and human physiology. Applied instinctively long before scientific articulation, this complex ritual extended beyond materials to timing and behavior. Pre-sleep routines involved tending fires, rearranging bedding, and sometimes small acts of storytelling or vocalization, reinforcing social cohesion, signaling safety, and even soothing the mind. Anthropological evidence suggests that such rituals had psychological benefits, creating a sense of security and predictability in a world dominated by unpredictability and threat. The cognitive architecture behind these behaviors reflects early human ingenuity, where every decision, choice of bedding plant, depth of fur layering, placement of the body, was a form of problem solving that balanced energy expenditure, heat retention, and risk mitigation. Seasonal variation added another layer of complexity. The bedding that preserved warmth in the dead of winter required recalibration with the arrival of thawing spring, demanding both flexibility and foresight. This adaptive strategy also influenced mobility. Portable bedding could be dismantled and carried, leaving no trace for predators to follow, while permanent or semi-permanent caves accumulated layers over generations, creating stratified thermal comfort zones that subtly recorded the passage of time and use. Beyond mere survival, these early beds were incubators of culture, spaces where the interplay of comfort, safety, and sociality nurtured cooperation, communication, and even early expressions of identity. The tactile qualities of furs and grasses, combined with the olfactory environment of smoke, earth, and dried plant matter, created a multisensory experience that was both functional and emotionally sustaining, a precursor to our modern understanding of sensory comfort and mental health. The careful attention to bedding also reflects early ecological literacy. Humans read the subtle differences between moss species, the insulating qualities of various grasses, the moisture-retaining capacity of different leaves, and even the heat retention properties of animal pelts. These choices were informed not only by trial and error, but by a growing body of oral knowledge passed down through generations, creating a cumulative understanding that blurred the lines between instinct, learned skill, and proto-scientific reasoning. This mastery of warmth was intertwined with diet, fire management, and social organization. Proximity to stored food, rotation of firewood, and communal sleeping arrangements all optimized energy conservation, revealing a holistic approach to life that integrated sleep, sustenance, and social bonds into a single adaptive strategy. In essence, the cozy winter beds of prehistoric humans were not simple shelters, but dynamic instruments of survival and culture, where every fiber, every layer, every nuance of placement and orientation mattered. They were laboratories of human ingenuity, meticulously designed to preserve life, enhance comfort, and foster social cohesion in environments that demanded constant vigilance. Understanding these early innovations reframes our perception of prehistoric life. Far from being mere struggle, it was a sophisticated interplay of observation, experimentation, and adaptation, where the pursuit of warmth and rest became a quiet yet profound expression of human intelligence. The lessons embedded in these ancient beds continue to resonate, reminding us that comfort, care, and attentiveness to one's environment are not modern luxuries, but timeless strategies that have shaped human survival from the earliest winters. Each layer, each contour, each choice of material reflects an intimate dialogue between humans and their surroundings, a dialogue that extended beyond mere survival to the creation of spaces that nurtured the body, soothed the mind, and strengthened the bonds that allowed communities to endure. This first encounter with intentional bedding was a transformative moment in human history, marking the convergence of biology, culture, and environment, and laying the foundation for every innovation in domestic comfort that would follow. In these frozen landscapes, the quiet hum of wind against stone and the muffled crackle of fire were accompanied by the deliberate arrangement of furs, grasses, and leaves, a nightly testament to the ingenuity and resilience of humans, whose pursuit of warmth and security shaped the course of survival, culture, and ultimately the human story itself. Beyond the mere construction of winter beds, early humans developed a profound sensitivity to the subtleties of thermal comfort, integrating natural physics with instinctive knowledge in ways that blurred the line between survival strategy and artistry. Every gust of wind, every drift of snow, every variation in rock density was accounted for in the placement of bedding, reflecting an intimate dialogue with the environment that required acute observation and patience. In caves, the contours of the rock determined the thermal gradient. A shallow recess near the cave's mouth might feel warmer during daylight hours, but would become a wind channel at night, while deeper niches offered steady, insulated temperatures, protected from drafts and precipitation. These choices demonstrate an early, nonverbal understanding of airflow and convection, anticipating what modern architects now codify in thermal engineering. Bedding placement was also influenced by the behavior of animals, both predator and prey, whose patterns offered warnings and cues about safety. The scent of neighboring fauna, subtle scratch marks on stone, or the presence of insect larvae could alter how furs and grasses were layered, where the body was positioned, and how fire was managed to balance warmth with minimal exposure. Such environmental literacy extended to the choice of materials. Mosses, for instance, were not chosen solely for softness but for their hygroscopic qualities, which allowed them to absorb moisture while maintaining insulation. Grasses and reeds were selected for their resilience and compressibility, creating a structure that would not collapse under the weight of repeated use. While furs were often rotated between the most exposed surfaces and inner layers, maximizing longevity and thermal efficiency, archaeological analyses reveal that these bedding structures were often multi-layered complexes, with alternating strata of ash, plant matter, and animal pelts, forming a composite system that regulated humidity, trapped heat, and even repelled parasites. Ash, gathered from hearths and sometimes deliberately placed, functioned as a desiccant, preventing rot and discouraging insects, while also providing a subtle reflective surface to bounce residual warmth back toward the sleeper. Such innovations indicate that early humans understood cause and effect in the context of comfort and survival, applying empirical observation in a systematic, almost experimental manner. Social considerations were equally pivotal. In communal shelters, beds were arranged to optimize both warmth and social cohesion. Larger members of the group, capable of generating more body heat, were often placed strategically near weaker individuals or infants, their own warmth radiating outward, a form of natural thermal synergy that reinforced both survival and social bonding. The arrangement of beds also reflected hierarchy, kinship, and trust, with the most sheltered positions often reserved for elders or leaders, signaling both practical concern and emerging social structures. Anthropological evidence suggests that bedtime routines extended well beyond the physical placement of bedding. The careful tending of fires, preparation of warm furs, and layering of plant matter were accompanied by low tones of conversation, repetitive gestures, or humming. Early humans intuitively created a soothing sensory environment to ease transition from wakefulness to sleep. This integration of environment, material, and ritual demonstrates a sophisticated cognitive framework, where the act of sleeping was recognized as both a physiological necessity and an opportunity for social reinforcement. Furthermore, the management of heat within these early shelters reflects an understanding of the delicate balance between retention and ventilation. Fires were positioned to maximize radiant warmth without producing smoke accumulation, while bedding placement allowed for sufficient airflow to prevent suffocating conditions or the buildup of dampness. Observations of thermal gradients likely influenced the rotation of sleepers and the adjustment of bedding throughout the night, creating a dynamic system in which human behavior responded continuously to environmental feedback. Seasonal variations demanded additional ingenuity. As winter progressed, snow accumulation altered wind patterns, humidity levels shifted, and the thermal properties of plant matter changed, necessitating constant adaptation. Early humans responded by layering additional insulation, repositioning beds, or incorporating newly gathered materials, a form of environmental calibration that mirrored the feedback loops observed in modern sustainable design. This adaptability was also evident in mobility strategies. Portable bedding allowed for temporary camps to be established in optimal microclimates, while permanent shelters accumulated complex stratified beds over generations. Such sites effectively became repositories of knowledge, where the remnants of previous users informed subsequent generations, creating continuity and refinement of comfort techniques. The psychological dimension of these spaces was equally critical. The act of preparing for sleep, carefully arranging materials, and maintaining warmth likely contributed to a sense of control and safety in an unpredictable environment. Sleep in these conditions was not merely a biological necessity, but a cultivated experience that enhanced alertness, social trust, and mental resilience, reflecting an early understanding of the interplay between environment, behavior, and cognitive well-being. Fire, in particular, served as both a physical and symbolic anchor. Its presence influenced not only temperature, but social interaction, storytelling, and the transmission of knowledge. The glow of embers reflected on furs and walls, creating a visual rhythm that signaled time, reinforced spatial awareness, and possibly even aided in regulating circadian patterns. The placement of beds in relation to fire also demonstrates careful risk management, balancing proximity for warmth with distance to prevent accidents or burns. Nutritional strategies were intertwined with bedding practices. Protein-rich foods, consumed in the evening, provided internal heat generation, while high-fat reserves allowed for sustained warmth overnight. Bedding, fire, and food became interconnected systems, each amplifying the efficacy of the others. Physiological insights, though unconscious, emerged from observation of body responses. The insulating properties of various materials, the impact of moisture on hypothermia risk, and the thermal contribution of neighboring bodies informed iterative improvements over generations. Even subtle cues, such as the direction of prevailing winds, the orientation of the body to the cave walls, and the density of plant matter, reveal an attentiveness that borders on engineering. By integrating sensory awareness, material science, and social structure, early humans transformed the simple act of lying down into a multi-layered survival strategy, one that nurtured physical health, reinforced group cohesion, and fostered a sense of mastery over a harsh environment. Cultural echoes of these practices appear in ritualized bed preparation, where repetitive gestures, tactile engagement with materials, and communal cooperation strengthened social bonds and transmitted knowledge. The selection and layering of bedding materials thus functioned as both practical and cultural communication, signaling care, expertise, and inclusion within the group. In effect, these early beds were microcosms of human intelligence, self-contained systems in which physics, biology, and culture coalesced. They reveal a species deeply attuned to the nuances of its environment, capable of manipulating space, material, and social dynamics to produce optimal conditions for survival and comfort. Through meticulous observation, experimentation, and communal learning, prehistoric humans not only survived winters that could easily extinguish life, but also created enduring practices that shaped cognitive, social, and cultural development. In the quiet, frost-ridden shelters of ancient landscapes, the interplay of fire, bedding, and bodies produced a rhythm of life that echoed the subtle pulse of the natural world, a rhythm that provided warmth, security, and continuity, allowing humans to endure, innovate, and ultimately thrive. The cozy winter beds that arose from this interplay were not mere artifacts. They were expressions of foresight, ingenuity, and empathy, tangible manifestations of the human drive to convert vulnerability into comfort and uncertainty into stability. In this delicate orchestration of environment, material, and human presence, the earliest sleepers perfected a balance between the exigencies of survival and the innate desire for comfort, laying the groundwork for every future innovation in domestic life, social cohesion, and cultural expression. As early humans refined the construction and placement of their winter beds, they also began to integrate subtler survival strategies that extended beyond warmth and comfort, blending sensory awareness, communal vigilance, and ritualized practices into a single, continuous nightly experience. In the dim recesses of caves or rock shelters, where shadows danced against stone walls and the chill of night seeped inexorably into every crevice, sleep became an orchestrated endeavor. Observing the behavior of nocturnal predators, wolves, hyenas, or bears, early humans learned to align their bedding not merely with thermal efficiency, but with safety, selecting sites that allowed rapid escape routes while minimizing exposure. The very orientation of a bed could signal survival priorities. Heads facing inward toward the shelter's depth, bodies nestled against earthen walls that radiated residual heat, and peripheral positions reserved for those capable of alerting the group to movement or sound. Every individual's placement was a calculated decision, reflecting a sophisticated understanding of both risk management and group dynamics. Communal sleeping arrangements further amplified safety and warmth. Clustering together created thermal synergy, allowing body heat to circulate efficiently while simultaneously reinforcing trust and social cohesion. The arrangement of individuals reflected subtle hierarchies and kinship structures, where infants and elders often occupied the most protected positions, while robust adults took on peripheral roles, their bodies forming a living shield against both environmental elements and potential predators. Beyond the immediate physical benefits, these arrangements reinforced cognitive and emotional networks, as the proximity of others provided sensory feedback that enhanced alertness and reduced stress, enabling a form of shared vigilance that extended the group's effective survival capacity. Sensory engagement with the environment became both practical and ritualized. The careful tending of fires, adjustment of bedding layers, and arrangement of protective plant matter were accompanied by soft vocalizations, humming, or rhythmic movements, behaviors that serve to calm the mind, reinforce social bonds, and structure the transition from wakefulness to sleep. Such practices reveal an early understanding of what modern neuroscience recognizes as the interplay between environmental cues, emotional regulation, and sleep quality. Bedding materials themselves carried complex significance. Furs, grasses, mosses, and leaves were chosen not only for their physical properties, but also for tactile, olfactory, and acoustic qualities, contributing to a multisensory environment optimized for comfort and alertness. The layering of materials created microclimates, regulating humidity, distributing weight, and mitigating pressure points, while the scents of smoke, earth, and dried plants provided sensory anchors that subtly reinforced spatial familiarity and safety. Seasonal variation further complicated this intricate system. Winter storms altered cave microclimates, snowdrifts blocked entrances, and shifting wind patterns demanded adaptive responses in bedding design and placement. Portable bedding allowed temporary camps to exploit microhabitats, while permanent shelters accumulated stratified layers, recording repeated human interaction and environmental adjustments. Each generation inherited a composite knowledge base, blending empirical observation with cultural memory, producing beds that were simultaneously functional, adaptive, and culturally expressive. The interaction between fire and bedding was central to this system. Fire produced radiant heat that penetrated layers of bedding, while embers and ash served additional purposes, disinfecting materials, repelling pests, and reflecting warmth back toward the sleepers. Strategic placement of fire in relation to beds demanded spatial reasoning, attentiveness to smoke dispersal, and careful management of fuel, all performed with a precision born of necessity. Nutritional strategies complemented these practices. Evening consumption of protein and fat-rich foods enhanced thermogenesis, while hydration management reduced risk of nocturnal chill or dehydration. Bedding, fire, and food became interdependent systems, optimized to conserve energy, maximize warmth, and reduce risk. Physiological observation, though intuitive, informed iterative refinement, noticing which layers retained heat best, how body position affected circulation, and how moisture accumulation impacted insulation. This feedback loop fostered a proto-scientific approach, where experimentation and experience guided improvements in sleep quality, energy conservation, and group cohesion. Social rituals emerged naturally from these practices. The act of preparing bedding, tending fires, and arranging communal spaces became a shared, structured activity, reinforcing cooperation, transmitting knowledge and embedding cultural identity into everyday survival routines. Oral instruction, gestural demonstration, and participatory learning ensured continuity, while the physical structures of beds, layered, stratified, and carefully maintained, served as tangible repositories of this knowledge. Beyond survival, these early sleeping arrangements subtly shaped cognitive and cultural development. The emphasis on comfort, security, and sensory harmony may have facilitated dreaming, reflection, and problem-solving, creating mental space for abstract thought and planning. The regular rhythms of firelight, the tactile feedback of layered furs, and the hum of communal activity contributed to circadian regulation, emotional stability, and heightened awareness. In essence, these beds were laboratories for human adaptation, where every choice, material selection, spatial positioning, fire management, and social arrangement reflected an integration of biology, environment, and culture. Moreover, the symbolic aspects of bedding cannot be overlooked. The care invested in arranging nests of furs and grasses, the protection afforded to infants and elders, and the subtle hierarchies reflected in sleeping arrangements all communicated values of empathy, responsibility, and community. Even the smallest gestures, smoothing a layer of moss, adjusting a hide, repositioning a companion, carried layered meaning, reinforcing the social fabric and nurturing collective memory. Archaeological sites provide glimpses into these practices. Depressions in earth, stratified plant layers, traces of ash, and remnants of burnt bedding indicate repeated care, maintenance, and innovation over generations. The complexity and refinement of these beds reflects sustained attention to detail, a cumulative knowledge system that transcended individual lifespans and connected communities across space and time. Physiologically, these innovations had profound consequences. Proper insulation, strategic body positioning, and communal heat sharing reduced the risk of hypothermia, preserved energy for daytime activity, and supported musculoskeletal development. Over time, such practices may have influenced human anatomy subtly, reinforcing endurance, core strength, and thermal resilience, illustrating the interplay between behavior, environment, and evolution. The cognitive implications are equally remarkable. Planning bedding arrangements required spatial reasoning, anticipation of environmental conditions, and predictive understanding of material behavior, skills foundational to problem-solving, tool-making, and abstract thought. Observing cause and effect relationships, testing configurations, and transmitting successful strategies cultivated attention, memory, and reasoning abilities. In effect, the construction and use of cozy winter beds were crucibles for cognitive, social, and cultural evolution, shaping not only survival strategies, but also the trajectory of human intelligence. Nightly practices reinforce these developments through ritualized repetition, the process of preparing for sleep, layering materials, tending fires, and coordinating communal arrangements embedded procedural knowledge and cultural norms, creating continuity and stability in an unpredictable environment. Sleep itself, cushioned, insulated, and socially structured, became a restorative, adaptive process that enhanced both individual and group resilience. Each layer of bedding, every adjustment of fire or plant material, and each choice of proximity to other group members represented a confluence of observation, empathy, and ingenuity. In this way, the winter bed transcended its immediate function, becoming a microcosm of early human ingenuity, a space where survival, comfort, cognition, and culture intersected. The mastery of these practices, honed over millennia, laid the foundation for all subsequent innovations in domestic life, social organization, and environmental adaptation, marking the winter bed as one of the earliest and most profound testaments to human creativity and intelligence. Within these frost-bound shelters, life and learning intertwined in a rhythm governed by firelight, tactile engagement, and shared vigilance, producing warmth, safety, and continuity in a world that demanded constant adaptation. In the quiet intimacy of layered furs and grasses, humans were not merely surviving. They were cultivating comfort, connection, and culture, creating spaces that nurtured the body, stabilized the mind, and reinforced the social bonds that ensured the continuity of their communities. As early humans advanced their understanding of bedding and shelter, they began to harmonize their immediate environments with long-term survival strategies, subtly manipulating microclimates within caves, rock shelters, and temporary encampments to maximize thermal comfort while minimizing exposure to predators and disease. The meticulous arrangement of bedding was no longer merely a response to cold, but an integrated system combining knowledge of airflow, humidity, fire dynamics, and spatial organization. In deeper recesses of caves, sleepers leveraged the natural thermal mass of stone to retain warmth accumulated during daylight, while layers of insulating vegetation acted as barriers against conductive heat loss to the earthen floor. The geometry of the sleeping area, concave depressions, mounds of plant matter, and strategic layering of furs was adjusted according to prevailing wind patterns, seasonal shifts, and the proximity of water sources, reflecting an empirical grasp of environmental physics that guided nightly decisions. Fire was employed not only as a heat source, but as a dynamic tool for manipulating these microclimates. Embers were placed to radiate heat toward bedding while minimizing smoke inhalation, and ash, scattered carefully beneath and around sleeping nests, served multiple functions, from moisture regulation to pathogen control and insect deterrence. Such deliberate interplay of fire, bedding, and shelter placement demonstrates early humans' capacity for predictive modeling. They understood that small adjustments in arrangement could significantly impact sleep quality, energy preservation, and overall survival. Tool use became an integral part of this process, with sharpened stones and bone implements facilitating the preparation of plant matter, the trimming of animal hides, and the construction of supportive bedding frameworks. Even rudimentary weaving or tying techniques were employed to bind grasses or moss into more cohesive mats, enhancing insulation and longevity. The choice of materials reflected both practicality and nuanced knowledge. Some furs, rich in undercoat, provided superior insulation, while certain mosses retained warmth even when damp. Leaves with specific textures reduced heat loss, while preventing condensation from reaching the sleeper. This careful selection indicates an empirical cataloging of material properties across generations, creating an intergenerational repository of knowledge that combined experimentation, observation, and cultural transmission. Social strategies were tightly woven into these practices. Nightly routines involved coordinated efforts among group members to gather, prepare, and arrange bedding materials, fostering cooperation, communication, and mutual trust. The act of collectively maintaining the sleeping area strengthened group cohesion, reinforced hierarchies, and allowed for subtle nonverbal instruction, ensuring that knowledge about optimal bedding practices was preserved and disseminated across generations. This interplay of social structure and environmental manipulation also had profound psychological effects. Being enveloped in a well-prepared sleeping nest, surrounded by trusted companions and a controlled microclimate, created a sense of security and predictability, which mitigated stress and enhanced cognitive function. Sleep in these conditions was restorative not only for the body, but for attention, memory, and emotional regulation, providing the neurological foundation for complex planning, problem-solving, and social reasoning during waking hours. Seasonal variations introduced additional layers of sophistication. As winter deepened, early humans adjusted bedding thickness, rearranged insulation, and experimented with the placement of furs and plant matter to counter increased frost penetration and wind chill. Portable bedding allowed groups to exploit thermal niches in temporary camps, demonstrating both flexibility and foresight in resource management. Permanent shelters, conversely, accumulated multi-generational layers of plant matter, ash, and furs, creating stratified systems that preserve knowledge about optimal thermal and spatial arrangements over decades. The physiological benefits of these practices were remarkable. Properly insulated beds reduced energy expenditure during sleep, maintained core body temperature, and protected against frostbite and hypothermia. Strategic body positioning, combined with the thermal synergy of clustered sleeping arrangements, optimized circulation and musculoskeletal comfort, minimizing strain and fatigue while enhancing readiness for daytime activity. Evidence suggests that even infants and the elderly were integrated into these arrangements with careful consideration of their thermal needs, reflecting empathy, foresight, and nuanced understanding of human physiology. The cognitive dimension extended to spatial reasoning and planning. Selecting a site for bedding required evaluation of environmental variables, prediction of airflow and temperature gradients, and calculation of potential predator exposure. Preparing and maintaining layered bedding involved sequential reasoning, problem solving, and attention to detail. These nightly practices fostered procedural memory, abstract thinking, and anticipatory cognition, skills that would underpin later innovations in toolmaking, shelter construction, and social organization. Cultural implications were equally significant. The meticulous care invested in bedding conveyed social information, signaling competence, attentiveness, and commitment to communal welfare. Rituals surrounding pre-sleep preparation, arranging bedding, tending fires, positioning individuals, reinforced shared norms and values, embedding social cohesion into daily survival strategies. Archaeological evidence supports this interpretation. Stratified bedding layers, traces of repeated fire management, and meticulous arrangement of furs and plant matter indicate a combination of practical and symbolic attention, suggesting that early humans viewed sleep preparation as both functional and socially meaningful. The integration of fire, bedding, and spatial organization created a dynamic feedback system in which environmental conditions, material properties, and human behavior continuously informed one another. Small adjustments in ash placement, bedding layers, or fire position produced measurable effects on warmth, airflow, and moisture, demonstrating an empirical understanding of cause and effect relationships in environmental manipulation. The adaptive nature of this system extended beyond the immediate shelter. Selection of bedding sites was informed by broader ecological knowledge, including terrain, wind patterns, predator behavior, and seasonal availability of materials. By aligning sleeping arrangements with landscape features and natural microclimates, early humans maximized safety and comfort while conserving energy for foraging and hunting. This approach reflects a sophisticated integration of environmental literacy, practical experimentation, and forward-thinking planning. The interplay of social, physiological, and environmental factors underscores the complexity of early bedding strategies. Thermal comfort was inseparable from group dynamics, cognitive function, and survival outcomes. Each layer of moss or fur, every ember's placement, and all positional arrangements contributed to a holistic system designed to sustain life and nurture community. Over time, this system facilitated the emergence of cultural knowledge and shared practices, creating continuity between generations and establishing the bed not merely as a survival tool, but as a crucible for social learning, problem-solving, and cultural identity. In this context, the winter bed emerges as a nexus where biology, cognition, sociality, and environment converge. The careful orchestration of materials, fire, and human placement demonstrates an empirical sophistication and an intuitive understanding of interdependent systems that prefigures later technological and architectural innovation. These early sleepers were not passive recipients of environmental conditions. They actively manipulated space, materials, and social structures to achieve optimized living conditions, embodying resilience, creativity, and foresight. Ultimately, the winter beds of prehistoric humans were more than physical platforms. They were adaptive microcosms, laboratories of environmental management, social cooperation, and cognitive development. Within these layered nests of furs, grasses, and ash, humans created a harmonious interface between body, mind, and environment, converting vulnerability into security and uncertainty into predictability. Through this interplay, Early humans not only survived the harshest winters, but cultivated the cognitive, social, and cultural capacities that would shape the trajectory of the species. Every layer, every adjustment, and every coordinated action was a deliberate, learned response to environmental challenges, reflecting the ingenuity, attentiveness, and resilience that define the earliest expressions of human intelligence. In the quiet, frost-laden shelters, life was not merely endured. It was meticulously orchestrated, embedding warmth, comfort, and continuity into the very fabric of human existence, a testament to the enduring power of observation, experimentation, and collaboration in the shaping of survival, culture, and civilization itself. The ingenuity of early humans extended far beyond the mere construction of insulated bedding. It encompassed a profound orchestration of the environment itself, transforming raw shelters into living systems attuned to temperature, airflow, and sensory perception. In the shadowed recesses of caves and rocky overhangs, where darkness thickened and the winter wind could strip warmth from exposed skin within minutes, beds were positioned with deliberate attention to microclimates. The natural curvature of stone walls, the thermal mass of rock, and the gentle slopes of the earth all informed where a sleeping nest could retain the most residual heat from sunlight or hearth embers, while remaining protected from drafts. Fires were carefully tended, not simply as sources of light or warmth, but as dynamic regulators. Embers were strategically placed to radiate heat across bedding layers, while smoke was directed to minimize inhalation, maintain air quality, and perhaps even deter insects. The interaction of fire and bedding created a delicate balance, where warmth, ventilation, and humidity were continuously monitored and adjustments made intuitively throughout the night. Bedding materials themselves were selected with nuanced understanding of their physical and chemical properties. Mosses, for example, were valued not only for softness, but for their capacity to absorb moisture and release it slowly, preventing condensation from chilling the sleeper. Grasses, reeds, and dried leaves provided structural support while trapping heat, and furs with dense undercoats retained warmth even under severe frost. The arrangement of these materials, thicker layers beneath, softer layers above, alternating textures, formed composite systems that moderated pressure points, preserved circulation, and maintained thermal stability over prolonged periods. Social dynamics were inseparable from these innovations. Bedding placement within communal shelters reflected kinship, trust, and hierarchical structures. Infants, the elderly, and other vulnerable members were strategically positioned to maximize protection and warmth, while stronger adults formed living barriers at peripheries, creating both physical and social insulation. Cooperative routines for preparing and maintaining bedding reinforced communal bonds, transmitted knowledge across generations, and embedded cultural values into the very act of sleep preparation. These practices were accompanied by ritualized behaviors that strengthened psychological resilience. Low vocalizations, humming, or rhythmic gestures as beds were arranged and fires tended created a calming atmosphere, reduced stress, and structured the transition from wakefulness to sleep. Such routines not only reinforced social cohesion, but also established predictability and safety, providing cognitive anchors in a perilous environment where threats were constant and life was measured in degrees of warmth. Seasonal shifts introduced additional challenges and refinements. As winter deepened, snow accumulation altered cave entrances, wind patterns changed, and moisture levels in plant matter varied, necessitating adaptive strategies. Bedding was thickened, furs rotated, moss layers replenished, and portable bedding transported to temporary microclimates, demonstrating flexibility, foresight, and an understanding of local ecological conditions. Multi-generational shelters accumulated stratified layers, effectively creating historical records of human interaction with the environment. Each layer of ash, grass, moss, or fur bore witness to the evolution of techniques, materials, and social practices over decades. Physiologically, these innovations had profound effects. Optimized insulation reduced metabolic expenditure during sleep, preserved core body temperature, and minimized the risk of frostbite or hypothermia. Careful positioning, along with the thermal synergy of clustered sleeping arrangements, enhanced circulation, minimized strain on joints and muscles, and allowed for restorative rest that fueled daytime activity and hunting. Infants, elders, and injured individuals were integrated thoughtfully, reflecting a deep, intuitive understanding of human needs and vulnerabilities. Cognitive development was also intertwined with these practices. Site selection, bedding preparation, and fire management demanded spatial reasoning, predictive planning, and attention to cause and effect relationships, fostering procedural memory and problem-solving skills, observation of material properties, experimentation with layering, and intergenerational knowledge transmission cultivated abstract thinking and analytical reasoning. In essence, sleep preparation became a cognitive training ground where observation, experimentation, and environmental feedback honed abilities critical to survival, social cooperation, and cultural innovation. The symbolic dimensions of bedding were equally significant. Careful arrangement of hides, moss, and furs communicated attentiveness, skill, and social responsibility, while the act of tending communal nests reinforced shared values and collective identity. Even the smallest gestures, adjusting a layer, repositioning a companion, smoothing a mat, carried social meaning, signaling empathy, competence, and commitment to group welfare. Archaeological evidence substantiates this complexity. Stratified plant layers, repeated fire markings, and meticulously arranged furs indicate both functional and symbolic attention, suggesting that early humans imbued sleep preparation with cultural as well as practical significance. Fire, bedding, and social arrangement functioned as an integrated system in which each element continuously influenced the others. Shifts in embers placement, compression of bedding layers, or positioning of bodies affected thermal efficiency, airflow, and comfort, creating a dynamic feedback loop in which observation and action coalesced into refined nightly strategies. Site selection extended beyond immediate comfort. Terrain, predator patterns, and seasonal resource availability informed decisions, ensuring survival while optimizing energy expenditure and safety. These intertwined practices reinforced physiological health, cognitive capacity, and social cohesion, illustrating that early winter beds were not passive resting places but active instruments of adaptation, learning, and cultural transmission. In these beds, humans were architects of both space and behavior, translating empirical observation into practical solutions and subtle rituals. The careful orchestration of materials, fire, and human placement exemplifies a holistic understanding of survival, where biology, cognition, and sociality intersected. Each choice, a layer of moss, a fur's orientation, a companion's position, was deliberate, shaped by observation, experimentation, and the transmission of knowledge. Over time, such practices nurtured resilience, foresight, and collaborative intelligence, laying the groundwork for the complex social, cognitive, and cultural capacities that would define human evolution. In this context, the winter bed emerges not merely as a functional object, but as a nexus of human ingenuity, integrating environmental mastery, social strategy, and cognitive development. These layered nests, warm and resilient against the harshest winters, stand as testaments to the adaptability, creativity, and empathy that characterize early humans. Life within these frost-bound shelters was meticulously orchestrated. A delicate dance of firelight, tactile engagement, and coordinated action produced warmth, safety, and continuity, transforming vulnerability into security and uncertainty into predictability. Within the quiet intimacy of these beds, humans cultivated comfort, connection, and culture, creating spaces that nurtured the body, stabilized the mind, and reinforced the social bonds essential for survival and communal continuity. By the time early humans had perfected the basic architecture of warmth and safety within their winter beds, their innovations extended into realms of sensory engagement, subtle engineering, and experimental adaptation, transforming each sleeping nest into a microcosm of environmental intelligence and cultural expression. The textures, scents, and even acoustics of these early sleeping spaces were carefully orchestrated to enhance comfort, alertness, and mental stability. Furs were selected not only for insulation, but for tactile contrast, layering coarser pelts beneath finer undercoats to create cushioning that distributed weight evenly while allowing subtle ventilation between layers. Moss and dried grasses provided spring-like resilience, compressing under the body to maintain ergonomic contours over repeated use, while also creating soft muffling that softened the impact of movement, muted footsteps within the shelter, and reduced ambient noise from the outside world. Even the scent of these materials contributed to the experiential environment. The earthy aroma of moss, the musky warmth of cured furs, and the faint smoke from embers created a sensory framework that promoted relaxation and psychological stability. reducing stress in the otherwise perilous winter environment. Within communal shelters, the spatial arrangement of beds evolved into an intricate choreography that balanced warmth, social bonds, and alertness. Peripheral sleepers acted as sentinels, their presence amplifying collective vigilance, while central positions were reserved for infants, elders, and other vulnerable members who received maximal warmth and protection. This system functioned as a social microcosm, fostering empathy, cooperation, and tacit communication, as each individual's positioning and movement carried implicit information about status, trust, and responsibility within the group. Such arrangements were reinforced by nightly rituals that guided the transition from wakefulness to sleep, combining fire tending, material layering, and coordinated movements with subtle vocalizations or gestures. These rituals, repetitive yet adaptive, produced predictable sensory patterns that signaled security and preparedness, shaping both cognitive and emotional regulation. Early humans were effectively creating a form of sensory architecture. Light, texture, sound, and scent were orchestrated to facilitate restorative sleep, while simultaneously maintaining environmental awareness. Seasonal variability drove continuous experimentation and adaptation. As winter intensified, bedding layers were thickened, moss and grasses were replenished, and furs rotated to optimize insulation. Portable bedding enabled temporary relocation to microclimates, offering superior protection, while permanent shelters accumulated stratified layers of ash, plant matter, and furs that served as cumulative records of prior generations' innovations. Archaeological evidence demonstrates these practices through the presence of layered sediments, impressions in bedding, and fire-altered plant materials, revealing sophisticated manipulation of thermal, tactile, and olfactory properties. Material innovation went hand in hand with environmental mastery. Early humans experimented with combinations of moss, grasses, furs, and leaves to optimize thermal retention, moisture wicking, and comfort. Ash and soot were deliberately incorporated, not only to reflect heat and regulate moisture, but potentially as early antiseptics or insect deterrents, demonstrating a nuanced understanding of chemical and physical interactions long before formal scientific recognition. These practices also influenced physical development. Repeated use of supportive, ergonomically arranged bedding reduced strain on joints and musculature, preserved energy, and enhanced mobility and stamina during daylight activities. Infants and elders benefited disproportionately from these arrangements, reflecting an intuitive grasp of differential physiological needs and a communal ethic of care. Cognitive development was equally intertwined with these innovations. Selecting sites, arranging materials, and monitoring thermal dynamics required spatial reasoning, sequential planning, and predictive analysis. The iterative experimentation with layering, material choice, and environmental positioning fostered problem-solving skills, observation, and abstract thinking. Intergenerational knowledge transmission ensured that effective strategies persisted and evolved, creating a cumulative cultural intelligence that informed subsequent innovations in shelter, clothing, and fire management. Beyond survival and cognitive benefits, these sleeping spaces cultivated cultural and symbolic dimensions. The deliberate care invested in arranging bedding, positioning individuals, and tending fires conveyed social competence, empathy, and commitment to communal welfare. Ritualized behaviors embedded cultural norms into daily survival practices, ensuring that preparation for sleep was both functional and socially meaningful. The physical structures of bedding, layered, stratified, and meticulously maintained, became tangible repositories of communal memory and environmental knowledge. The interplay of fire, bedding, and spatial arrangement created dynamic microenvironments in which early humans could regulate temperature, airflow, and comfort while maintaining awareness of predators, environmental hazards, and each other. The integration of sensory, social, and material factors produced a sophisticated feedback loop. Adjustments to one element influenced others, requiring constant observation, evaluation, and adaptation. These practices illustrate a level of environmental literacy, cognitive flexibility, and social coordination that laid the foundation for complex human innovation. Moreover, these winter beds were laboratories of anticipatory cognition, predicting changes in weather, material behavior, or group dynamics demanded foresight, flexibility, and rapid decision-making. Repeated experimentation with bedding arrangements, layering techniques, and material combinations cultivated a proto-engineering mindset, where empirical observation was systematically applied to optimize both comfort and survival outcomes. Physiologically, these advances ensured that humans could conserve energy, maintain core temperature, and reduce stress on the cardiovascular and musculoskeletal systems during long, cold nights. The sensory architecture of these spaces, tactile, olfactory, and auditory, reinforced calmness, alertness, and social cohesion, enabling early humans to thrive cognitively and socially, despite environmental challenges. Over time, these innovations shaped cultural practices, social hierarchies, and interpersonal dynamics. The careful orchestration of space, materials, and behavior reinforced values of cooperation, attentiveness, and communal responsibility. Even subtle gestures, such as smoothing a mat, rotating a fur, or repositioning a companion, transmitted information about care, competence, and social bonds. Through these seemingly simple actions, the winter bed became a locus for cultural transmission, empathy, and the cultivation of collective intelligence. In essence, the winter bed was both a functional survival tool and a medium of human ingenuity, integrating environmental mastery, cognitive development, social cohesion, and cultural expression. It demonstrates how early humans transformed vulnerability into security, discomfort into comfort, and environmental complexity into structured, adaptive, and socially meaningful spaces. Within these layered nests of moss, grasses, and furs, illuminated by firelight, humans were not only surviving, they were actively cultivating intelligence, empathy, and culture. These beds were microcosms of human adaptation, reflecting an ongoing dialogue between body, mind, environment, and community, a synthesis that continues to shape the way humans design, inhabit, and experience space even in the modern era. By orchestrating every aspect of their sleeping environment, early humans created sanctuaries that nurtured physical well-being, cognitive acuity, and social cohesion, transforming the simple act of sleep into an adaptive, creative, and culturally significant practice that would reverberate through millennia. As the evolution of winter beds continued, early humans increasingly integrated the dimension of ritual and symbolism into their nightly routines, transforming the act of preparing, arranging, and occupying these spaces into a subtle yet profound cultural practice. Each bed, layered with moss, grasses, and furs, became a locus of intergenerational knowledge, social cohesion, and embodied tradition, where the physical arrangement mirrored the group's understanding of environmental adaptation, hierarchy, and communal care. The rituals surrounding sleep began with deliberate observation of the environment, assessing wind direction, temperature gradients, and humidity levels, as well as noting signs of predator activity or changes in the surrounding terrain. These observations informed precise placement of bedding, where each fur, each moss mat, and each layer of ash was positioned to maximize warmth, protect the body from moisture, and maintain a sense of spatial order within the shelter. The sensory environment, tactile, olfactory, and auditory, was carefully cultivated, creating a subtle interplay of textures, scents, and ambient sounds that signaled safety, routine, and predictability. Moss provided a soft, springy foundation, grasses cushioned joints and absorbed residual moisture, and furs offered insulation, comfort, and familiar scent cues that reinforced a sense of home and stability. Firelight added a dynamic, visual rhythm, flickering across the textured surfaces of bedding and cave walls, providing both warmth and psychological reassurance. Within communal settings, these preparations were highly coordinated. Social organization dictated that certain individuals, often the elders or more experienced members, guided the placement of layers, while others gathered materials, adjusted embers, or maintained airflow. The physical act of arranging bedding became a shared ritual, a dance of coordinated movements that reinforced trust, cooperation, and the social bonds that were critical for survival. Infants and vulnerable members of the group were placed strategically, protected at the center of clusters, while stronger adults formed peripheral barriers, both generating warmth and serving as early warning systems against predators or environmental threats. Such arrangements demonstrated a sophisticated understanding of thermal synergy, social responsibility, and environmental risk management, integrating biology, behavior, and community into a single adaptive system. These rituals also carried symbolic weight. Careful attention to bedding conveyed respect, competence, and empathy, signaling commitment to collective welfare. Adjustments to furs, rotation of mats, or smoothing of moss layers were not only practical acts, but communicative gestures, embodying values of attentiveness, skill, and interdependence. Through these subtle actions, the winter bed became a medium for cultural transmission, where knowledge about material properties, environmental conditions, and social organization was passed from generation to generation without words, encoded in touch, observation, and shared practice. Seasonal shifts amplified the complexity of these practices. As winter deepened, materials were replenished, bedding thickness adjusted, and portable nests repositioned to exploit favorable microclimates. Permanent shelters accumulated layered evidence of these practices over years and decades. Ash deposits, compressed plant layers, and rearranged furs served as stratified records of experimentation, adaptation, and cultural memory. This accumulation not only enhanced thermal efficiency, but also provided continuity and guidance for younger members, embedding an empirical understanding of environmental management and survival strategies into the very structure of daily life. Cognitive development was intertwined with these rituals. Planning bedding arrangements required spatial reasoning, predictive analysis, and procedural memory. Attending to sensory cues honed attention and observation, and monitoring group dynamics cultivated social intelligence. These nightly practices fostered problem-solving skills and abstract thinking, as individuals evaluated cause and effect relationships between materials, fire placement, and environmental conditions. The ritualized nature of these activities provided structure, reducing cognitive load and stress, while reinforcing shared norms and communal identity. Physiologically, these practices conferred remarkable advantages. Optimally layered beds preserved core temperature, reduced energy expenditure, and mitigated risks of frostbite or hypothermia. The careful positioning of individuals within clusters maximized heat retention and minimized vulnerability, while repeated exposure to well-prepared bedding maintained musculoskeletal integrity and circulation, supporting overall health and resilience. The sensory dimension, soft textures, familiar scents, muted ambient sounds, reinforced relaxation, mental alertness, and sleep quality, contributing to cognitive and emotional stability. Over time, the integration of ritual, social coordination, and environmental manipulation fostered cultural innovation. Observational learning and participatory practice created a cumulative knowledge system where effective techniques were preserved, refined, and transmitted across generations. Even minor adjustments, such as repositioning a moss layer or altering fur orientation, reflected both experimentation and an intuitive understanding of cause and effect relationships, providing the foundation for empirical reasoning that would underpin future technological and social advancements. These winter beds also served as symbolic spaces of protection, continuity, and communal identity. The very act of preparing and occupying them reinforced the group's cohesion, signaling care for one another and embedding cultural values into everyday survival practices. The tactile and olfactory familiarity of the bedding materials anchored individuals within their environment, reducing stress and creating a psychological buffer against the uncertainty of the external world. Fire, moss, furs, and grasses collectively produced an environment that was both functional and emotionally stabilizing, illustrating a sophisticated interplay of physical, cognitive, and social intelligence. Archaeological evidence confirms the enduring complexity of these practices. Stratified bedding layers, traces of repeated fire tending, and carefully arranged furs and plant matter indicate that early humans invested considerable effort in constructing and maintaining their sleeping spaces, reflecting not only concern for thermal efficiency, but also attention to social and symbolic dimensions. These beds were living systems where environmental manipulation, social behavior, and sensory experience converged in a continuous adaptive feedback loop. The integration of these elements, thermal management, sensory optimization, social coordination, and ritualized practice, demonstrates that early winter beds were far more than passive resting places. They were dynamic sites of cultural, cognitive, and physiological development, enabling humans to survive harsh conditions while simultaneously cultivating intelligence, empathy, and shared knowledge. Within these layered, meticulously arranged nests, individuals experienced a sense of security, continuity, and belonging, while simultaneously participating in the transmission of essential skills and social norms. In this way, the winter bed became both a sanctuary and a classroom, where survival, culture, and cognition were inseparably intertwined. Every movement, smoothing a mat, rotating a fur, adjusting embers, was imbued with practical, social, and symbolic significance, transforming nightly sleep into a multidimensional practice that shaped human development across generations. These innovations in bedding and ritualized behavior were fundamental to the emergence of complex human societies, laying the groundwork for later architectural design, social organization, and cultural expression. The winter bed was not merely a product of environmental adaptation. It was an incubator for cognitive and social evolution, a carefully orchestrated interface between body, mind, and community that nurtured resilience, creativity, and collective intelligence. In the intimate, frost-bound spaces of early shelters, humans were simultaneously surviving, observing, teaching, and connecting, creating layered nests that held warmth, knowledge, and culture, a testament to the ingenuity, empathy, and foresight that define the earliest expressions of human intelligence and adaptation. As the refinement of winter beds progressed, early humans began to integrate purposeful innovation that extended beyond layering furs and mosses, incorporating tools, structural supports, and novel materials to optimize comfort, thermal efficiency, and resilience against environmental hazards. The crafting of bedding evolved into a meticulous practice in which the careful selection of plant fibers, animal hides, and mineral elements was combined with the judicious use of sharp stones, bones, and primitive weaving techniques to produce sleeping surfaces that could endure repeated use, resist moisture, and enhance warmth. Tools allowed early humans to prepare materials more effectively. Grasses could be trimmed and bundled for uniform thickness, mosses loosened to retain pliability, and hides stretched or stitched to fit the contours of the shelter, creating an ergonomically adaptive surface. In some cases, plant fibers were twisted or interlaced to form mats that maintained structural integrity over extended periods, while furs were arranged in overlapping layers to trap air, creating micro-insulated pockets that mirrored principles of modern thermal design. The integration of fire with bedding structures also became more sophisticated. Stones were occasionally positioned to absorb and radiate heat, while embers were distributed in a controlled manner to warm specific areas of the bedding without overexposing occupants to smoke or flame. Ash and soot were deliberately used beneath bedding layers, reflecting an empirical understanding of moisture control, heat reflection, and hygiene. Such innovations were not merely functional. They required observation, planning, and iterative experimentation, reflecting cognitive processes that combined foresight, trial and error, and intergenerational knowledge transfer. Social organization remained central to these developments. Communal shelters demanded coordination of labor, with certain individuals gathering and preparing materials, others constructing bedding frameworks, and experienced members supervising placement to ensure both thermal efficiency and social harmony. Placement of individuals within clusters reflected both physiological needs and social structure. Infants and elders received the greatest protection and warmth, while peripheral adults assumed sentinel roles, creating living barriers that enhanced group survival. These arrangements reinforced implicit hierarchies, fostered empathy, and transmitted knowledge through participatory practice, embedding cultural norms into everyday survival routines. Beyond structural and social innovation, early humans also began to explore sensory optimization in bedding. The textures of moss, grasses, and furs were arranged not solely for insulation, but to modulate tactile feedback, cushioning pressure points, and reducing discomfort during prolonged sleep. Scent played a subtle but significant role. The earthy aroma of moss, musky warmth of cured furs, and residual smoke from embers produced a multi-sensory environment that reinforced familiarity, safety, and cognitive stability. Even sound was accounted for. Softer layers muted the crackle of fire, the movement of companions, or the subtle groans of the earth under freezing temperatures, creating a calm auditory landscape conducive to deep rest and alertness upon awakening. Seasonal variation continued to drive adaptive innovation. As winter intensified, bedding arrangements were thickened, furs rotated, and portable mats transported to more favorable microclimates. Temporary shelters could be rapidly prepared, while permanent sites accumulated stratified bedding layers that recorded repeated innovation over decades. Such stratification provided empirical feedback for subsequent generations, who learned to distinguish materials and configurations that maximized warmth, durability, and comfort. Physiologically, these innovations produced remarkable benefits. Optimized insulation reduced caloric expenditure during sleep, maintained core body temperature, and protected against frostbite and hypothermia. Strategic body positioning, combined with layered materials, enhanced circulation, relieved musculoskeletal strain, and promoted restorative rest critical for daytime survival activities, from hunting to gathering. Cognitive development was simultaneously enhanced. The design, preparation, and continuous refinement of bedding required planning, observation, and problem solving, fostering spatial reasoning, predictive modeling, and abstract thought. Individuals learned to evaluate cause and effect relationships between material properties, environmental variables, and thermal outcomes, producing iterative knowledge that informed both individual decision-making and communal practices. Ritualization remained an integral dimension of these innovations. Preparing bedding, tending fires, and arranging sleeping positions followed predictable patterns, embedding social norms, values, and practical knowledge into the fabric of daily life. Actions such as layering moss in a precise orientation, rotating furs to optimize insulation, or smoothing plant matter conveyed attentiveness, skill, and communal care, signaling responsibility and reinforcing social bonds. These rituals transformed the winter bed into a living laboratory of culture, cognition, and social intelligence, where physical comfort, environmental mastery, and social cohesion intersected. Archaeological evidence supports these conclusions. Impressions of layered plant matter, burn marks indicative of controlled fire use, and meticulously arranged furs suggest a level of technological sophistication and intentionality far beyond basic survival. These beds were dynamic systems, constantly adjusted in response to environmental feedback, social needs, and material properties, reflecting a level of empirical observation and adaptive reasoning foundational to human ingenuity. In this context, early winter beds became incubators for broader innovation. Mastery of material properties, thermal dynamics, and spatial arrangement informed subsequent advances in clothing, shelter construction, and tool use. While the cognitive skills honed in these practices, planning, experimentation, and sensory awareness, fed into the larger trajectory of human technological and social evolution. Symbolically, these beds conveyed security, continuity, and cultural identity. Every act of layering, arranging, or adjusting communicated care, skill, and participation in shared knowledge. The tactile and olfactory familiarity of bedding materials provided psychological stability, anchoring individuals within their environment and reinforcing a sense of belonging. Fire, furs, and mosses collectively created a controlled microcosm of warmth, sensory engagement, and social trust, demonstrating how early humans transformed environmental challenges into structured, adaptive, and meaningful experiences. In sum, the evolution of winter beds represents a convergence of material innovation, environmental intelligence, social coordination, and cognitive development. Each sleeping nest was more than a platform for rest. It was an engineered space in which the body, mind, and community were simultaneously nurtured. Early humans were architects, engineers, and social organizers, translating empirical observation into functional and symbolic systems that enhanced survival, reinforced cultural cohesion, and fostered the cognitive flexibility necessary for ongoing adaptation. Within these carefully layered spaces of moss, grasses, and furs, illuminated by controlled firelight, humans not only endured the harshest winters but also cultivated intelligence, empathy, and continuity, laying the foundation for the complex interplay of environment, cognition, and culture that continues to define human experience. Through iterative experimentation, attentive observation, and socially embedded practice, these early winter beds became a nexus of survival, comfort, and innovation, demonstrating that the pursuit of warmth was inseparable from the cultivation of human ingenuity, sociality, and cultural memory. With the continual refinement of winter beds, early humans began to embed increasingly sophisticated layers of communal knowledge, environmental awareness, and psychological strategy into the act of sleeping. Transforming these spaces into more than functional shelters, they became arenas for cultural continuity, cognitive development, and social stability. By this stage, the arrangement of bedding was deeply intertwined with survival, as every decision about material, placement, and layering reflected accumulated understanding of thermal physics, airflow dynamics, predator behavior, and human physiology. In communal shelters, spatial organization became a carefully calibrated system, balancing warmth, security, and social hierarchy. Vulnerable individuals, infants, elders, and the infirm occupied the central areas, surrounded by stronger, more resilient members who served simultaneously as thermal generators and living sentinels. Peripheral positions, while offering less immediate warmth, provided early detection of environmental or predatory threats, creating a distributed network of vigilance that enhanced collective safety without compromising comfort. The selection of bedding materials and their placement reflected a refined understanding of sensory and physiological interactions. Moss layers, interwoven with grasses, acted as thermal buffers, absorbing residual moisture while maintaining insulation and providing subtle tactile feedback that reduced pressure points and minimized strain during prolonged sleep. Furs were layered strategically, alternating coarse and fine pelts to trap air effectively, while allowing airflow, reflecting empirical observation of material properties over repeated use. Ash, carefully positioned beneath or between layers, served as a moisture regulator, insect deterrent, and thermal reflector, demonstrating the multidimensional thinking applied to even the smallest aspects of sleep preparation. Fire integration remained a central component, functioning not only as a heat source, but also as a tool for environmental management. Embers were placed to optimize radiant warmth without creating hazardous smoke accumulation, while stones near hearths absorbed heat during the day and slowly released it at night, providing passive thermal regulation. Such practices reveal a nuanced understanding of energy conservation and environmental feedback, cultivated through experience, observation, and intergenerational teaching. Psychological resilience was equally cultivated through these practices. The structured routines surrounding sleep, layering materials, tending embers, and arranging individuals within the communal space produced a sense of predictability and security, mitigating anxiety in an environment marked by constant threat. Sensory cues, tactile textures of furs and mosses, subtle scent of ash and cured hides, flickering firelight, reinforced familiarity and safety, anchoring cognitive processes and enabling restorative sleep. The predictable rhythm of these nightly practices facilitated circadian regulation, mental relaxation, and emotional stability, creating conditions that supported attention, memory consolidation, and problem-solving during daylight activities. Social learning and cultural transmission were embedded into every aspect of bedding preparation. Younger members observed and participated in material gathering, layering, and positioning, internalizing techniques and protocols without verbal instruction. The physical structures themselves, layered, stratified, and maintained over years, served as tangible records of accumulated knowledge, encoding information about material properties, thermal efficiency, and spatial organization that could be interpreted and refined by successive generations. This interplay between hands-on practice, observation, and environmental feedback formed a dynamic learning system, fostering cumulative intelligence and technical skill. Seasonal changes demanded adaptive innovation, ensuring that the bedding system remained resilient and responsive. Snow accumulation, wind shifts, and variations in moisture content required adjustments in layering, rotation of furs, and relocation of portable mats to exploit optimal microclimates. In permanent shelters, repeated use produced stratified bedding that recorded generations of experimentation, demonstrating empirical understanding of thermal performance, durability, and comfort. Physiologically, these innovations had measurable advantages. Carefully engineered bedding preserved core body temperature, reduced metabolic energy expenditure during sleep, and mitigated frostbite or hypothermia risk. Strategic body placement, combined with thermal synergy from communal clustering, supported circulation, alleviated musculoskeletal strain, and enhanced restorative sleep, providing energy and resilience for survival-oriented daytime activities such as hunting, foraging, and tool-making. Cognitive development was simultaneously nurtured. The complex interplay of materials, placement, fire management, and environmental observation demanded spatial reasoning, sequential planning, and problem-solving. Individuals monitored feedback from materials, compressibility, moisture retention, insulation performance, and adapted strategies iteratively. Over time, these experiences cultivated foresight, abstract reasoning, and adaptive intelligence, laying the foundation for future technological and cultural advancements. Ritualized behavior continued to reinforce social cohesion and cultural identity. Actions such as smoothing moss layers, rotating furs, or adjusting fire embers became patterned and meaningful gestures, conveying skill, care, and participation in the community. These rituals transmitted knowledge tacitly while reinforcing values of cooperation, attentiveness, and empathy, embedding social norms into the routine of nightly preparation. Sensory engagement extended beyond the tactile and olfactory dimensions. The interplay of flickering firelight across layered bedding, the muted auditory environment created by soft moss and grasses, and the subtle warmth radiating from clustered bodies contributed to a psychologically stabilizing environment that supported emotional regulation, attentional focus, and restorative sleep. The winter bed was therefore not merely a survival tool, but a structured interface in which physiology, cognition, and social dynamics converged. Material innovation, environmental manipulation, social coordination, and ritualized practice collectively produced a dynamic, adaptive system in which comfort, safety, and learning were inseparable. Archaeological evidence supports this multi-layered perspective. Stratified plant matter, impressions from repeated use, fire-altered bedding, and evidence of careful fur arrangement demonstrate long-term maintenance, experimentation, and intergenerational knowledge transfer. These beds functioned as living repositories of practical, social, and cultural intelligence, linking individual survival with collective memory and resilience. Symbolically, the winter bed became a medium for expressing social cohesion, empathy, and cultural continuity. The care invested in layering furs, positioning individuals, and tending embers communicated attentiveness, skill, and responsibility, signaling shared values and reinforcing group identity. Each nightly routine, from material gathering to final adjustments, embodied a synthesis of survival strategy, cognitive reasoning, and cultural practice. In essence, the winter bed had evolved into a crucible of human ingenuity, where environmental mastery, cognitive development, social intelligence, and cultural memory coalesced. It was a microcosm in which survival imperatives intersected with the cultivation of knowledge, skill, and empathy, producing outcomes that extended far beyond the immediate need for warmth. Within these frost-laden shelters, early humans had transformed the act of sleep into a complex, adaptive system that nurtured the body, honed the mind, and strengthened social bonds. Every layer of moss, every adjustment of a fur, every ember's placement reflected a calculated, iterative process that balanced environmental forces, physiological needs, cognitive demands, and social obligations. Through this intricate orchestration, winter beds became living laboratories of survival, culture, and intelligence, demonstrating that human ingenuity and collaboration could convert vulnerability into resilience, discomfort into comfort, and unpredictability into stability. By embedding ritual, innovation, and social learning into the very act of sleeping, early humans ensured that each night contributed not only to rest and recovery, but also to the continuity of knowledge, the reinforcement of communal bonds, and the evolution of cognitive and cultural capacities that would define the species for millennia to come. As winter beds matured into sophisticated microcosms of survival, early humans began to intertwine symbolism, experimental cognition, and complex sensory engagement into the very fabric of nightly rest, transforming what was once purely functional into an intricate system that nurtured mind, body, and culture simultaneously. Beyond the practical considerations of insulation, layering, and fire management, the positioning and arrangement of each element carried implicit meaning. The careful overlap of furs, the orientation of moss mats, and even the subtle angles of fire embers became coded expressions of care, social hierarchy, and communal memory. These beds were no longer inert objects. They were living systems in which human attention, skill, and observation continuously interacted with environmental forces, producing dynamic feedback loops that shaped both individual experience and collective knowledge. Within communal shelters, spatial arrangements became increasingly sophisticated, reflecting the social logic of protection, vigilance, and emotional resonance. Central positions were reserved for the most vulnerable members, infants, elders, and injured individuals, ensuring maximum warmth and protection, while peripheral adults formed living barriers against environmental threats and potential predators. Such arrangements were far from static. Nightly observation of thermal efficiency, predator signs, or airflow prompted subtle adjustments, demonstrating a fluid and anticipatory understanding of environmental systems. These interactions reveal not only empirical intelligence, but also heightened social awareness. Positioning within the bed cluster communicated trust, responsibility, and empathy, reinforcing relationships without a single spoken word. Sensory orchestration played a critical role in cognitive and emotional regulation. The tactile contrast of moss, grasses, and furs created micro-textural feedback that promoted comfort while subtly cueing body awareness and alignment. Olfactory stimuli, such as the earthy scent of moss, the musky warmth of furs, and the lingering aroma of embers, provided psychological anchors, reducing stress and reinforcing familiarity in a harsh environment. Acoustic modulation, achieved by layering materials to muffle both internal and external sounds, created an auditory landscape conducive to restorative sleep while maintaining a subtle capacity for environmental awareness. Fire, strategically tended and positioned, contributed not only warmth but also dynamic visual and thermal stimuli, creating a flickering rhythm that stabilized circadian patterns and provided subtle cues for safety. Timing and orientation within the shelter. Innovation extended into material experimentation. Early humans observed, tested, and refined the properties of plant fibers, mosses, furs, and hides to optimize thermal retention, moisture management, and tactile comfort. Bundling grasses, interweaving moss, and layering hides of differing textures reflected both empirical experimentation and abstract reasoning, demonstrating the capacity for iterative problem solving. Even ash and soot were deliberately incorporated beneath bedding layers to regulate moisture, enhance insulation, and deter insects, illustrating multidimensional thinking that bridged biology, physics, and chemistry without formal abstraction. Cognitive engagement was amplified by these practices. Site selection, material preparation, layering, and placement demanded spatial reasoning, sequential planning, and anticipatory thought. Feedback from environmental variables, temperature gradients, airflow, and moisture retention fed into adaptive strategies, cultivating predictive intelligence, problem solving, and procedural memory. The interplay of individual observation with communal practice reinforced learning, ensuring that successful innovations were transmitted and refined across generations, creating a cumulative knowledge system encoded not in language alone, but in material culture and practice. Social rituals intertwined seamlessly with these innovations. Repetitive patterned actions, smoothing moss, adjusting furs, rotating embers, functioned simultaneously as practical steps and social signals, conveying competence, care, and participation in communal knowledge. These rituals embedded cultural norms into everyday survival, ensuring continuity of practice, transmission of values, and reinforcement of social cohesion. The very act of sleep preparation became a medium for cultural expression, where skill, attentiveness, and empathy were encoded into material manipulation. Seasonal dynamics prompted ongoing adaptation and experimentation. Snow accumulation, wind shifts, and moisture variations required not only adjustments in bedding thickness and material rotation, but also relocation to microclimates with favorable thermal characteristics. Permanent shelters accrued stratified bedding over years and decades, creating physical archives of innovation that provided empirical guidance to successive generations. Observing the performance of materials and arrangements in varying conditions enabled early humans to refine strategies iteratively, fostering both technological skill and cognitive flexibility. Physiological outcomes of these practices were profound. Optimized insulation preserved core temperature, reduced energy expenditure, and protected against frostbite or hypothermia. Clustering individuals strategically maximized thermal efficiency, circulation, and joint alignment, while sensory-rich environments enhanced relaxation, restorative sleep, and emotional stability. Collectively, these factors supported physical resilience, cognitive acuity, and readiness for daytime survival activities such as foraging, hunting, and tool production. The symbolic dimension of the winter bed grew increasingly complex. Each gesture, from layering furs to adjusting embers, communicated intentionality, care, and social connection. Sensory consistency, familiar textures, smells, and sounds provided continuity, anchoring individuals psychologically within their environment and reinforcing a sense of communal identity and safety. Beds were simultaneously functional, social, and symbolic, embodying the intertwined demands of survival, culture, and cognition. Archaeological evidence underscores the sophistication of these practices. Stratified plant and fur layers, impressions of repeated use, and controlled fire placement reflect deliberate planning, maintenance, and experimentation over generations. These artifacts demonstrate that early humans understood the multidimensionality of their sleeping environments, integrating thermal, tactile, olfactory, acoustic, and social considerations into a coherent system that balanced immediate survival with long-term cognitive and cultural development. In essence, the winter bed had evolved into a dynamic, living system, a nexus where human ingenuity, environmental literacy, social intelligence, and sensory mastery converged. It exemplified how survival imperatives could catalyze cognitive growth, cultural expression, and social cohesion simultaneously. By continuously observing, experimenting, and transmitting knowledge, early humans transformed the simple act of resting into a crucible of innovation, problem-solving, and communal learning. Within these layered nests, illuminated by carefully tended embers and insulated against the harshest elements, humans were not merely resting, they were cultivating intelligence, empathy, continuity, and adaptability. Each night became a rehearsal of skills, a reinforcement of cultural values, and a laboratory for cognitive development. Through iterative refinement, environmental manipulation, and ritualized practice, the winter bed became a cornerstone of human resilience, demonstrating the interdependence of body, mind, environment, and society. In this quiet, frost-laden intimacy, the convergence of warmth, sensory harmony, and social order created a space in which humans could thrive cognitively, physically, and emotionally, transforming vulnerability into security and daily survival into a medium of enduring ingenuity and cultural continuity. The winter bed, thus, was more than an artifact of necessity. It was a living testament to human adaptation, foresight, and creativity, a structured sanctuary in which the complex interplay of materials, fire, social interaction, and cognition produced not only comfort and safety, but the foundations of intelligence, culture, and collaborative identity that would define the species for millennia to come. The maturation of winter beds signified more than material and environmental sophistication. It reflected a profound understanding of psychological resilience, sensory optimization, and the subtle dynamics of social learning, transforming nightly sleep from a mere survival necessity into a multifaceted process of cognitive, emotional, and cultural reinforcement. Early humans recognized, perhaps intuitively, that the quality of sleep directly influenced alertness, decision-making, and social functioning, and they engineered their sleeping environments accordingly. The layering of furs, mosses, and grasses was not only a response to cold, but a deliberate modulation of tactile feedback, providing subtle cues to the body about posture, movement, and comfort. Moss offered spring-like elasticity, distributing pressure evenly and preventing musculoskeletal strain over extended rest periods. Grasses and leaves, interwoven beneath and atop furs, regulated moisture while producing minute variations in texture that encouraged micro-adjustments of the body, maintaining circulation and optimizing thermal contact. These tactile strategies were intertwined with olfactory and auditory modulation. The earthy aroma of moss, musky warmth of cured hides, and subtle scent of lingering embers created a sensory scaffold that anchored attention, reduced stress, and promoted psychological stability. Even ambient sound was orchestrated. Layering bedding materials muffled external noise from wind, water, or predator movement, while soft interior surfaces dampened sounds generated by fellow sleepers, producing a controlled auditory environment that balanced restorative quiet with necessary alertness. Fire, positioned and tended with meticulous care, contributed to this sensory equilibrium, providing warmth, dynamic visual stimulation through flickering light, and a rhythmic auditory backdrop that synchronized with the human circadian system. Beyond sensory mastery, these winter beds functioned as arenas for complex social learning. In communal shelters, the arrangement of individuals reflected intricate social logic. Infants and vulnerable adults were centrally located, shielded both physically and socially, while peripheral adults formed a protective perimeter. This arrangement fostered empathy, trust, and mutual responsibility, embedding values of care and collaboration into nightly practice. Participation in bedding preparation, fire management, and microclimate adjustment allowed younger or less experienced members to acquire technical knowledge, environmental literacy, and social competence through observation, imitation, and guided involvement. These nightly engagements reinforced procedural memory, problem-solving skills, and adaptive reasoning, while the iterative process of adjusting materials and configurations promoted experimentation, abstraction, and anticipation of outcomes, forming the bedrock of cognitive development. Seasonal shifts further intensified these processes. As winter deepened, variations in temperature, humidity, and wind forced continuous recalibration of bedding layers, ember placement, and shelter microclimates. Portable mats and furs could be relocated to capitalize on thermal pockets, while permanent shelters accumulated stratified evidence of repeated adaptation. Each layer of moss, grass, or ash acted as both thermal buffer and empirical record, encoding prior solutions and failures that informed the next generation of sleepers. In this way, the winter bed became a repository of collective intelligence, bridging generations through tactile, visual, and olfactory cues. Physiologically, these innovations produced cascading benefits: optimized insulation, reduced energy expenditure, preserved core body temperature, and prevented frostbite or hypothermia. Strategic body placement and clustering enhanced thermal synergy, supported circulation, and relieved musculoskeletal stress, ensuring that the body could recover fully during prolonged periods of inactivity. Combined with sensory regulation, these strategies facilitated restorative sleep, improved cognitive function, and reinforced emotional equilibrium, directly influencing daytime performance in foraging, hunting, and social interaction. Cognitive development was inextricably linked to these environmental and social interventions. Site selection, material evaluation, layering, and fire management required advanced spatial reasoning, predictive modeling, and abstract thought. Feedback from environmental variables, temperature gradients, airflow patterns, and moisture levels necessitated ongoing problem-solving and iterative refinement. The integration of observation, experimentation, and cultural transmission created a cumulative knowledge system where effective strategies persisted and evolved, reinforcing both technical skill and adaptive intelligence. Symbolism and ritual were inseparable from these practices. Every adjustment of moss, fur, or ember conveyed skill, attentiveness, and social commitment. The tactile repetition of layering, smoothing, or rotating materials became a ritualized language, encoding cultural norms, intergenerational knowledge, and values of care into the nightly process. The sensory and spatial consistency of the sleeping environment reinforced communal identity, fostering a psychological sense of continuity, stability, and belonging even amidst the unpredictability of harsh winter landscapes. Innovation continued to flourish within these beds. Material experimentation, interweaving different plant fibers, layering hides of varying thickness, adjusting embers for targeted warmth, produced adaptive solutions to thermal and physiological challenges. Ash and soot were strategically placed to regulate moisture, repel insects, and reflect heat, revealing empirical insights into chemistry and physics that guided nightly decisions without formal abstraction. Over time, these cumulative innovations enhanced survival, efficiency, and comfort, while simultaneously cultivating problem-solving, foresight, and experimental cognition, bridging the practical and the intellectual. The winter bed was, therefore, a multi-layered instrument of human adaptation, simultaneously regulating thermal comfort, nurturing physiological recovery, fostering cognitive growth, and embedding cultural knowledge. Within this space, the body, mind, and social network converged in a continuous feedback loop, where observation informed action, action refined materials, and refined materials supported both survival and learning. Archaeological evidence corroborates this complexity. Stratified plant layers, impressions of repeated use, fire-altered bedding, and carefully arranged furs attest to a dynamic interplay of function. Ritual and experimentation sustained over generations. In essence, winter beds had become living laboratories of adaptation. They were not inert surfaces, but active systems through which humans mediated their environment, honed cognitive and social skills, and encoded cultural continuity. Every layer, adjustment, and coordinated action contributed simultaneously to warmth, comfort, knowledge transfer, and emotional security. These beds exemplified the capacity for humans to transform vulnerability into resilience, discomfort into comfort, and environmental unpredictability into structured, adaptive systems. Through iterative refinement, observation, and ritualized practice, early humans cultivated intelligence, social cohesion, and cultural memory, embedding survival, cognition, and community into a single, tangible nightly experience. In these frost-bound shelters, the synthesis of sensory orchestration, environmental mastery, social dynamics, and cognitive engagement produced conditions in which humans could thrive despite extreme conditions. Every act of tending embers, layering moss, or positioning a companion reinforced survival strategies, emotional regulation, and social learning. The winter bed was, in essence, a crucible of human ingenuity, where adaptive intelligence, cultural continuity, and psychological resilience were simultaneously nurtured, laying the groundwork for complex problem-solving, communal cooperation, and technological innovation in future generations. By this stage, winter beds had evolved into intricately orchestrated systems, merging technological sophistication, intergenerational knowledge transfer, and environmental adaptation into a singular nightly practice that extended far beyond mere survival. Early humans demonstrated a nuanced understanding of materials, thermal dynamics, and social organization, translating observation and experience into cumulative innovations that enhanced comfort, safety, and cognitive development. The integration of tools into bedding preparation marked a significant leap in complexity. Sharp stones, bones, and primitive carving implements allowed for the shaping, stitching, and layering of hides, while rudimentary weaving techniques were employed to create mats of interlaced grasses or plant fibers that maintained their structural integrity under repeated compression. Moss and leaves could be bundled and compacted with precision, producing resilient spring-like bases, while layered furs created insulative pockets that trapped air efficiently and evenly distributed warmth across the body. These innovations were not only practical, but also iterative. Repeated use and experimentation allowed early humans to evaluate the performance of different materials, combinations, and configurations under varying environmental conditions, fostering a sophisticated form of empirical problem-solving. Fire integration remained central to this technological and sensory system. Ember placement, stone positioning, and ash layering were calibrated to optimize radiant heat, control airflow, and mitigate smoke exposure, reflecting an advanced understanding of thermodynamics and environmental interaction. Stones heated during the day absorbed solar energy and radiated warmth through the night, while embers positioned near bedding edges created targeted heat zones that complemented natural insulation from furs and plant layers. Even small adjustments, shifting a fir, rotating a moss layer, or tilting a stone, produced measurable effects on comfort, demonstrating an intimate knowledge of cause and effect relationships and iterative learning processes. Social organization and knowledge transmission were deeply embedded in these practices. Communal shelters functioned as collaborative workshops, where the act of preparing bedding, tending fires, and adjusting microclimates provided continuous opportunities for observation, instruction, and apprenticeship. Younger members learned through participation, imitating actions, and internalizing procedures that encoded both practical and cultural intelligence. Elders and experienced individuals guided these processes, providing subtle cues, feedback, and demonstrations that reinforce social hierarchies, communal responsibility, and cooperative problem-solving. These nightly interactions embedded complex learning into routine survival, ensuring that technical skill, environmental literacy, and social knowledge were preserved and refined across generations. Sensory orchestration became increasingly sophisticated. Tactile layering of moss, grasses, and furs optimized pressure distribution, facilitated micro-adjustments, and maintained circulation, while the olfactory environment provided cues for familiarity, safety, and temporal patterns. Ambient sound was modulated through material arrangement, dampening external noise and the movement of companions while maintaining a subtle capacity for vigilance. Firelight created dynamic visual rhythms that synchronized circadian patterns and anchored spatial awareness, integrating sensory, physiological, and cognitive functions into a harmonious nightly experience. The winter bed also became a locus for psychological resilience. Structured routines, sensory consistency, and predictable spatial arrangements mitigated stress, reduced anxiety, and fostered a sense of continuity and safety in an otherwise unpredictable environment. The combination of tactile, olfactory, auditory, and thermal cues reinforced emotional regulation, supporting mental clarity, attentional focus, and restorative sleep. Physiologically, these practices conserved energy, maintained core temperature, and minimized the risk of frostbite, hypothermia, and musculoskeletal strain, enabling individuals to recover fully and perform optimally during daytime activities such as hunting, foraging, and tool production. Seasonal variation continued to drive adaptive innovation. Snow accumulation, wind shifts, and humidity changes necessitated adjustments to bedding thickness, material rotation, and shelter relocation to exploit favorable microclimates. Portable mats and furs allowed for rapid deployment in optimal locations, while permanent shelters accumulated stratified layers of moss, grasses, ash, and furs that acted as both thermal buffers and empirical archives. Each layer bore witness to experimentation, providing feedback for future generations and serving as a tangible record of environmental interaction, material efficacy, and social coordination. The symbolic and cultural dimensions of the winter bed were equally significant. Layering, smoothing, rotating, and adjusting materials became ritualized acts, communicating skill, attentiveness, and social responsibility. These gestures encoded cultural values into everyday practice, ensuring continuity of knowledge, reinforcement of social cohesion, and transmission of communal norms. The bed thus functioned simultaneously as a practical survival tool, a cognitive training ground, and a medium of cultural expression. Archaeological evidence of layered plant and fur remains. Impressions of repeated use and controlled fire placement illustrates the enduring complexity of these systems, revealing a dynamic interplay of material, environmental, social, and cognitive factors sustained over generations. In essence, the winter bed had evolved into a living laboratory, integrating technological ingenuity, environmental mastery, sensory optimization, and social intelligence. Each night, early humans engaged in an iterative process of observation, adjustment, and experimentation, balancing thermal comfort, physiological recovery, cognitive engagement, and social learning. The sleeping environment functioned as a nexus where body, mind, and community converged, producing outcomes that extended far beyond immediate survival. The cultivation of intelligence, empathy, collaborative skills, and cultural continuity. Within these frost-bound shelters, every adjustment, layer, and ember placement contributed to a system of adaptive resilience, embedding empirical knowledge and cultural memory into tangible, tactile, and sensory experience. Winter beds exemplified the seamless integration of survival, cognition, and culture, demonstrating that human ingenuity and collaborative intelligence could transform the harshest environmental conditions into structured, adaptive, and meaningful spaces. The interplay of material innovation, sensory orchestration, social learning, and ritualized practice created an enduring framework in which humans could thrive cognitively, physically, and socially, even in extreme winter landscapes. Each night became both a rehearsal of skill and a reinforcement of communal knowledge, producing layered nests that were simultaneously functional, educational, and culturally significant. By embedding observation, experimentation, and intergenerational teaching into the nightly ritual of sleep, early humans cultivated adaptive intelligence, social cohesion, and technological sophistication, transforming vulnerability into resilience, unpredictability into structure, and survival into a conduit for ongoing innovation. The winter bed, therefore, stands as a testament to the extraordinary capacity of humans to merge environment, cognition, and community into a single dynamic system, demonstrating how the pursuit of warmth and comfort catalyzed the development of intelligence, cultural continuity, and social complexity that would define the trajectory of our species for millennia. At the pinnacle of winter bed innovation, early humans had transformed these layered sanctuaries into highly adaptive systems that balanced risk mitigation, material engineering, environmental mastery, and social coordination in ways that reflected an unprecedented synthesis of cognitive, cultural, and physiological intelligence. The continual pressures of cold, moisture, and predation demanded not only effective insulation, but also a flexible framework that could absorb environmental unpredictability, distribute risk, and optimize survival outcomes. Material selection and layering strategies evolved accordingly. Moss was gathered from multiple microenvironments, with the most absorbent spring-like varieties reserved for the base to create a moisture-buffering foundation. Grass and leaves, carefully interwoven and compacted, produced resilient mats that maintained structural integrity while accommodating shifts in body weight, mitigating localized pressure and enhancing thermal efficiency. Furs of varying density were layered strategically to trap air, and provide adaptive insulation, while animal hides could be stitched or overlapped to form elevated sleeping platforms that further isolated the body from cold ground or residual moisture. Even ash and soot were integrated with foresight, not merely as moisture regulators or insect deterrents, but as thermal reflectors that redirected residual heat back into the sleeping zone, demonstrating a nuanced, empirical understanding of energy management and environmental physics. Fire management became an inseparable component of this adaptive system. Embers were positioned to create controlled heat gradients, while stones heated in the sun radiated warmth passively, minimizing fuel consumption and maintaining steady microclimatic conditions. Peripheral sleepers could subtly monitor environmental cues through smoke patterns, temperature changes, and sounds, creating a distributed early warning network that allowed the group to respond collectively to threats while minimizing individual exposure. These practices illustrate the complex interplay of environmental mastery, physiological regulation, and anticipatory cognition. The winter bed had become a dynamic interface in which sensory feedback, material properties, and social observation converge to produce a controlled and predictable microenvironment. Tactile engagement with moss, grasses, and furs allowed the body to adjust posture and alignment naturally, reducing strain and preserving energy during prolonged periods of inactivity. Olfactory and auditory cues created a stable sensory scaffold, reinforcing psychological safety, emotional regulation, and circadian synchronization. Firelight provided visual rhythm and spatial orientation, anchoring sleepers to both shelter and community. Social learning remained embedded within every facet of these practices. Younger individuals observed, participated, and internalized the strategies of elders and skilled members, translating tactile, visual, and auditory experience into procedural knowledge. Spatial arrangements reinforced social hierarchies and communal responsibility, with central positions for the most vulnerable and peripheral positions for Sentinel members. Through repeated participation, individuals acquired not only practical skills, but also the cognitive flexibility, foresight, and problem-solving capacity necessary to refine, adapt, and innovate over successive seasons. Seasonal variability continued to drive iterative experimentation. As temperatures dropped, wind patterns shifted, or snow accumulations altered microclimates. Bedding arrangements were adjusted dynamically, mats were relocated, furs rotated, embers repositioned, and shelters reorganized to exploit optimal thermal zones. Portable components allowed rapid response to changing conditions, while permanent structures accumulated stratified layers of moss, grasses, ash, and furs that served as empirical archives for material performance. Environmental adaptation and social coordination. These stratifications became tangible repositories of cumulative knowledge, encoding lessons learned and innovations discovered, ensuring that the successes and failures of one generation informed the strategies of the next. Physiological resilience was amplified by these practices. Optimized insulation and strategic positioning preserved core temperature, reduced caloric expenditure, and mitigated frostbite, hypothermia, and joint strain. Coordinated clustering enhanced thermal synergy, circulation, and sleep quality, directly supporting cognitive and physical performance during daylight activities such as hunting, foraging, and tool crafting. Sensory orchestration further reinforced psychological stability, creating an environment that balanced alertness with restorative calm, preparing individuals both physically and mentally for the unpredictable demands of survival. Cognitive complexity was inseparable from these innovations. Planning and executing multi-layered bedding, integrating fire, and adapting to environmental feedback required advanced spatial reasoning, sequential thought, and predictive modeling. Observing and interpreting subtle environmental cues cultivated attention, foresight, and analytical skill, while the integration of experimentation, adjustment, and social transmission created a cumulative knowledge system that underpinned both technological innovation and cultural continuity. Symbolically, the winter bed represented a confluence of protection, care, and communal intelligence. Layering, arranging, and adjusting materials communicated competence, attentiveness, and empathy. The deliberate organization of space and the ritualized sequence of preparation embedded cultural norms, reinforced social cohesion, and transmitted values of cooperation and foresight. The bed became a medium through which survival, cognition, and culture intersected, transforming nightly rest into a multidimensional practice that shaped human development across generations. Archaeological evidence attests to this sophistication. Stratified bedding layers, impressions from repeated use, evidence of fire integration, and the deliberate arrangement of furs and plant materials reveal sustained attention to functional, social, and symbolic dimensions of sleep. These beds were dynamic systems, continuously adjusted in response to environmental feedback, social needs, and material properties, reflecting the capacity for empirical observation, problem solving, and adaptive reasoning that defined early human ingenuity. Innovation extended beyond materials and fire to include the orchestration of social, spatial, and environmental variables. Nightly routines balanced vigilance, thermal efficiency, and comfort, producing a feedback loop in which each element influenced the others. Adjustments to moss thickness, fur layering, or ember placement had cascading effects on sensory experience, physiological recovery, and social coordination, illustrating a systems-level understanding of cause and effect that integrated body, mind, and community. In essence, the winter bed had become an integrative system of survival, cognition, and culture. It was simultaneously a thermal shelter, a laboratory of experimentation, a medium of social learning, and a repository of cultural memory. Through iterative refinement, early humans transformed vulnerability into resilience, uncertainty into structure, and nightly rest into a conduit for intelligence, empathy, and collaborative skill. Within these frost-bound, layered sanctuaries, humans orchestrated sensory, material, and social elements to produce an environment optimized for survival, learning, and cultural continuity. Every layer of moss, adjustment of fur, and placement of ember represented a calculated interaction with the environment, a rehearsal of cognitive skill, and a reinforcement of communal values. The winter bed thus stands as a testament to the ingenuity, foresight, and collaborative intelligence that define the human species, demonstrating that the pursuit of warmth and comfort catalyzed not only survival, but also the evolution of complex cognition, social cooperation, and cultural transmission that would shape humanity for millennia to come. As the winter bed reaches its culmination, one perceives it not merely as a place of rest, but as a nexus where human ingenuity, environmental mastery, cognitive development, and social cohesion converge in an intricate, living tapestry of survival and culture. Every layer of moss, every carefully rotated fur, every ember strategically positioned, tells a story of iterative experimentation, empirical observation, and intergenerational knowledge transfer that spans millennia. What began as a simple response to cold and discomfort had evolved into a dynamic, adaptive system capable of regulating temperature, moisture, and sensory input, while simultaneously cultivating intelligence, empathy, and cultural memory. Early humans transformed vulnerability into resilience through the careful orchestration of materials, fire, and social space, achieving a harmony between body, mind, and community that reflects the extraordinary cognitive and social capacities of our species. The winter bed functioned as a living laboratory of adaptive reasoning. Material selection, moss, grasses, furs, hides, ash, was informed by repeated observation and experimentation, each choice calibrated to optimize insulation, comfort, and durability. Layering strategies evolved over seasons, balancing thermal efficiency, tactile feedback, and moisture control, demonstrating an empirical understanding of physics and biology that predates formal abstraction. Fire placement and management added a dynamic element, modulating radiant heat, airflow, and visual rhythm, while stones and embers worked in tandem with layered materials to create consistent microclimates. Adjustments were iterative, responsive to environmental feedback, and shared socially, forming a continuous cycle of learning that reinforced both survival and cognition. Within this physical and sensory environment, social organization and cultural transmission were embedded seamlessly. Communal shelters were carefully arranged to maximize protection, warmth, and vigilance. Infants, elders, and vulnerable individuals occupied central positions, surrounded by peripheral adults who served as thermal generators and sentinels, creating a living network of resilience. Participation in bedding preparation, material adjustment, and fire tending provided opportunities for social learning, apprenticeship, and skill acquisition, embedding cultural knowledge and procedural expertise into daily survival practices. Ritualized acts, smoothing moss, rotating furs, arranging embers, became carriers of communal norms, transmitting values of attentiveness, cooperation, and empathy without the need for formal language. These sensory and spatial rituals also reinforce psychological stability, mitigating stress and uncertainty in an environment marked by extreme cold, unpredictability, and threat. Sensory orchestration within the winter bed exemplifies the subtlety of early human ingenuity. Tactile cues guided body alignment and micro-adjustments, distributing pressure and preserving circulation. Olfactory input, earthy moss, musky furs, lingering smoke, anchored perception and memory, producing emotional continuity and a sense of security. Auditory modulation, achieved through layered materials, dampened external noise while preserving awareness of environmental cues, allowing both rest and vigilance. Firelight created dynamic visual patterns that synchronized circadian rhythms, anchored spatial orientation, and provided subtle temporal cues. Together, these sensory inputs transformed the winter bed into an immersive, restorative environment, supporting both physical recovery and cognitive enhancement. Physiological and cognitive benefits were deeply intertwined. Optimized insulation and clustering reduced energy expenditure and protected against frostbite or hypothermia, while restorative sleep facilitated memory consolidation, attentional focus, and problem-solving ability. Iterative experimentation with materials, layering, and fire management cultivated advanced spatial reasoning, predictive modeling, and adaptive intelligence. Sensory-rich environments reinforced emotional regulation, psychological stability, and a sense of continuity across time, producing individuals capable of both immediate survival and long-term innovation. The winter bed also functioned as a medium of cultural continuity and symbolic expression. Layering, arranging, and adjusting materials encoded communal knowledge, social values, and practical skill into tangible structures that could be interpreted and refined by successive generations. Stratified bedding layers served as empirical archives of experimentation and refinement, allowing younger members to observe, learn, and innovate based on the collective experience of their ancestors. Each night became a rehearsal of cognitive, social, and environmental skills, reinforcing group cohesion while nurturing individual intelligence and adaptability. Seasonal and environmental variability drove continuous refinement and adaptation. Snow, wind, and moisture shifts demanded recalibration of bedding thickness, material rotation, ember placement, and microclimate exploitation. Portable mats and furs allowed dynamic response, while permanent shelters accumulated stratified evidence of long-term experimentation. Every adjustment reflected empirical reasoning, balancing immediate comfort with longer-term survival strategies, demonstrating a profound understanding of cause and effect relationships and adaptive resilience. Archaeological evidence attests to this sophisticated integration of function, cognition, and culture. Layered plant matter, furs, ash, and fire-altered bedding, carefully arranged and maintained over repeated use, reveal long-term attention to thermal, tactile, sensory, and social optimization. These beds were not inert objects, but dynamic systems in which material, environmental, and social factors continuously interacted, producing measurable improvements in survival, comfort, cognitive engagement, and communal cohesion. In reflecting upon the winter bed, one sees the embodiment of early human ingenuity, where survival imperatives catalyzed technological innovation, cognitive development, and cultural transmission simultaneously. These shelters illustrate that the pursuit of warmth and comfort was inseparable from the cultivation of intelligence, empathy, and social complexity. Each layer, adjustment, and ember placement represents the convergence of observation, experimentation, sensory awareness, and social reasoning, demonstrating that humans could transform environmental adversity into structured, adaptive systems that supported both body and mind. Ultimately, the winter bed stands as a microcosm of human resilience and creativity, revealing how environmental mastery, sensory orchestration, social learning, and cultural expression coalesced into a single, coherent practice that shaped both individual and collective capacity. Within these frost-bound sanctuaries, humans perfected a synergy of material innovation, cognitive engagement, social coordination, and sensory modulation, producing a living system in which survival, intelligence, and culture were inseparably linked. These beds represent the earliest evidence of humans transforming necessity into opportunity, discomfort into comfort, and vulnerability into resilience, forging a legacy of innovation and collaboration that echoes through millennia. As we trace the contours of layered moss, rotated furs and carefully tended embers, we perceive not only a response to winter's harshness, but the emergence of human intelligence, social sophistication, and cultural continuity. In this synthesis of body, mind, environment, and community, the winter bed becomes both a tangible artifact and a metaphor for the extraordinary capacities of our species. The ability to observe, experiment, adapt, and collaborate. The capacity to transform risk into resilience, cold into warmth, and daily routine into enduring knowledge. In the quiet intimacy of these frost-laden shelters, early humans were architects, engineers, psychologists, and social coordinators, orchestrating a delicate balance between comfort, survival, and continuity. The winter bed, in its ultimate form, exemplifies the power of cumulative innovation and the interplay of sensory, cognitive, social, and cultural dimensions in shaping human experience. Through these layered nests of moss, grasses, furs, and embers, we witness the foundations of intelligence, collaboration, and cultural memory being laid, a testament to the enduring human capacity to create order, meaning, and beauty from the challenges of an unforgiving world. In the end, the winter bed is not just a place of sleep. It is a living monument to human ingenuity, resilience, and the profound interconnection of environment, mind, and society, encapsulating the very essence of what it means to be human.